power chart. This is one of the slides from the textbook, but anybody ever hear of weighted data? So none of our data is weighted. Every day from the ATM withdrawal, each data is equivalent. It is as meaningful as the next day, right? But there is something called weighting data. Weighting, they give more influence to some data than others. And this example that I see here is an academic example. So it had the following situation. It had a course that was graded on several things, tests, a midterm, some lab work, some homework, final exam, and they were all weighted differently. I guess I can make that one bigger. That's probably as big as I can get, but if each of these pieces of data was weighted differently. And you can see that the test counts for 50%, so it's weighted the heaviest. And what happens here is if I have different weights on the data, then I take the piece of data and I multiply it, which is like applying the weight to it, giving it more credibility. And then I multiply those, and then I add all of these products together to get the mean. Now that 100 on the homework right here, it was only weighted at 5%, didn't do a lot to bring my grade up. I mean, it helped, but it didn't have the impact as the test and the midterm, because they were weighted more. And so the weights typically have to add up to what? 1. Typically we add them up to 1. Now, they don't have to, but in fact, in an example like this, we are. They have to be summed to 1 to make the denominator make sense, okay? Because we're gonna divide by a total of all the weights, which is 1. So in most stats book, this is the example that you give for weighted mean. But can somebody give me a real-life example where you might use weighting? Where would you go collect data and you would weight the data? That's like giving more influence to some data pieces and less to other data. Tyler?
Exchange rates.
In what?
For currency exchange rates.
Right?
Like weighting a euro to a dollar.
Yeah, I think that's more of like just the rate. I don't think you're I mean, it literally, you can convert a dollar to any other currency, but you're not really, yeah, Nick, can you think of something?
If you're like asking for opinions on a survey or something, you don't weigh like someone saying average as importantly as someone saying like really below average or really above average. Those might be more important to you, so you weigh them more.
Maybe, that would be a little dicey because I would think that everybody's opinion is important, but maybe, yeah. Chase, what were you going to say?
Like produce maybe.
Produce like vegetables? And
yeah, you weigh them and then they, I don't know, price per pound. Maybe I'm taking it too literally.
Yeah, I think you're guessing, but let me interject my thoughts. Okay. Let's say that we manufacture something and we get screws from 2 different suppliers, right? 2 different suppliers. Let's say that Claudia owns the manufacturing company and she buys literally screws, fasteners, okay, from 2 different suppliers. She buys them from Lourdes and she buys them from Brandon. That make sense? Now, she buys 2/3 of her screws from Brandon. She buys 1/3 of her screws from Lourdes. Make sense? and she says to, I don't know, Sonia, I want you to take 100 of the screws that Brandon sent to us, and I want you to see how many defects we got. And I want you to take 100 that Lourdes sent, see how many defects we got. Make sense? Now I want you to literally look at 100 of each. Now, each one of those defects shouldn't count for the same, because Brandon is supplying 2/3 of the screws. So if I find a defect in Brandon's case, okay, that's much more significant than if I find one over in Lourdes' case. That makes sense, everybody? So you would probably weight the data according to how much you're getting from each one, okay? Brandon is 66% of the grade for the defects. Lourdes is like 1/3 of the grade. Does that make sense to everybody? Yeah, Joe?
I guess the example might be like if you have various products that you ship on various trucks, and trucks carry different values worth of products, you'd see how quickly your value of products got somewhere on time, but you wouldn't weight the trucks the same. If certain trucks carry
Fair enough.
different
That's
values.
exactly right. So weighting takes place a lot, but it has a lot to do with the influence that each piece of data actually has. Is really what it boils down to. Okay, 3 slides, and let's take a break, okay? We've got a distribution up there on the board from our ATM withdrawals, and oh, here we go. I'm gonna go back one. There's just a couple of types of distribution shapes that we should be aware of, okay? One is, that we talked about briefly before, it's kind of a symmetrical, it's the left side, the right side look the same. You know, typically this is, we call mound-shaped, symmetrical. If your data looks like that, what we have, not really symmetrical, a little off, but if it's perfectly symmetrical, then all 3 of these measures line up. The mean, the median, the mode, they're in the same place. They're right in the middle. They're right here. They all line up. But in a couple other cases, they may not line up. Another type of shape and distribution that we'll see is basically flat. It's called a uniform distribution. It doesn't have a mode. There's no high point. Everything is equally likely. But the mean and the median line up because it's symmetric. Okay. Another common shape would be, we have a distribution that's skewed. Now, when I say skewed, that means if it's skewed to the left, it tends towards the negative side. And skewed is where the tail is. This slow build is the tail. The hard drop-off is not the tail. So skewed to the left, or skewed pointing to the negative, okay? If you have something that's skewed, then it tends to drag the mean away from the median. This is the opposite example of Sarah earning $1 million, okay? This is, she takes away $5 or something. But when skewed to the right, it will drag the mean to the right typically. So this is skewed to the right. The tail is to the right. Kind of a quick build up here, and the tail is slow decline to the right. Okay, skewed left or right. Okay, so question. And so hopefully you took some good notes on the worksheet. What we want to do after the break